Okay, so our Module 11 Systems Test Review Guide. Here are all the questions, of course, on your review guide. It might be kind of small depending on how your screen is, but I've already went ahead and written the questions down on the answer sheet so that we could just go ahead and work them out. So remember, we do have all the answers down here, and that is on your paper as well. But let's just go through the process, working them out, because obviously you're not going to have all the answers on the test. So, but it'll be nice to be able to check all of our work as we go here or when we finish up. So let's start with number 1 in graphing, right? Now the thing about this graphing one is it's not set up in slope-intercept form, which can make things a bit tricky. So what we're going to have to do is take one of these equations at a time, rearrange it into slope-intercept form, and then go graph it from there. So let's look at the first equation. We have 3x plus 2y equals 20. And now it's always a two-step process. What you want to do is move the x term first. So since it's a positive 3x, we'll subtract 3x on both sides. So this leaves us the equation with 2y on the left side equal to 20 and minus 3x on the right side. So we're going to put minus 3x plus 20. So we just kind of put these two terms over on this side of the equation, and the left side just has the 2y, because all we did was take the 3x term and simply kind of move it. So now we're close. We almost have y by itself, but we have to divide by that 2 to get rid of that 2. So divide by 2, and here's what we end up with. We end up with y all by itself equal to, this ends up being a fraction, but don't worry about it. We can leave it like that. That's kind of a good thing that it's a fraction, actually. So we have negative 3 over 2x. And then 20 divided by 2, we can simplify. We know 20 divided by 2 is 10, so plus 10. So now I have that equation in slope-intercept form, and I can graph it, right? So my y-intercept is at 10, so I'm going to go find 10 on the y-axis. So the y-axis is the one here up and down the middle. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That puts our y-intercept there. And our slope is negative 3, which means down 3. And the denominator is 2, which means we can go to the right 2. So down 3 and right 2 squares puts us here. And so we'll continue filling this in. Down 3 and right 2 every time. And we have our line. So we'll trace through that best we can. There we go. And so now we have to do the same thing for the second equation, which is negative 2x plus y equals 4. So we have to rearrange this one as well, but this one's not as difficult a process. We just have to move the x term first, and then there isn't a number like the 2 in the last one that we have to divide by. Because this y is by itself, there is no division here. So, well, it's sort of by itself, right? It's alone, it's just not necessarily by itself. We have to move this x term over. So since it's a negative 2x, we'll add 2x to both sides. That now leaves us the y all by itself on the left. And then I have 4 plus 2x on the right. Or you can just think of this as 2x plus 4. So now look, the y is already by itself because there's no number here to divide by or anything. So we're ready to go ahead and graph it. It's got the y-intercept at 4. So we'll go up on the y-axis, go up to 4, which is right here. And then our slope is 2, which means up 2. But don't forget to go right 1 as well. So up 2, right 1, up 2, right 1. Yeah, up 2, right 1, up 2, right 1. And then we can go backwards as well. Oh, I messed up. I realized it. I was wondering what something seemed wrong. If you're wondering what went wrong, it's the fact that this was a negative 4 and I wrote it down wrong. So my apologies there. You might have already noticed it. I did not notice it. It was a negative 4 the whole time, guys. The whole time. This is what happens when you don't write it down right. So a negative 4 is our y-intercept. Yada yada, which is down there, but still our slope is still 2 over 1, so we go up 2 and over 1. So a small little mishap, but I was able to catch myself and we're good. I was just checking to see if you were paying attention. That's what I was doing. You know, no big deal. Okay, so now they cross at this point here. So that's our solution. They cross at the point, it looks like 4, 4, x4, y4. So it looks like it crosses at the point 4, 4, which is cool. All right. And we could check our answer key as well, and we should see that. Yep, 4, 4. So now let's look at number 2. So again, we have the same problem where we have to rearrange the equations. So let's start with that first equation, negative 2x plus 2y equals 4. So we'll move the x term first. So since it's negative 2x, we'll add 2x. And so what that's going to do is it'll leave 2y on the left side, but on the right side, it'll have 4 plus 2x, or, positive 2x plus 4. And I did write this down right. Yes, I did. So we're good. Okay, now we have to divide by this 2 that's next to the y. So divide by that 2 to cancel it out, and then divide everything else by 2. So what we end up with is y by itself. 2 divided by 2 becomes 1x, and then 4 divided by 2 becomes 2. So we have 1x plus 2. So now we can graph it. Our y-intercept is 2. So we'll put our 2 on the y-axis. And our slope is 1, same as 1 over 1, which means we have to go up 1 and right 1. So that's going to put us like this. A lot of dots here. But there's your line. You want to try and make it pretty accurate and straight as possible, because the whole point is so that you can see where the lines cross. So you don't want to be lazy with the line. You want to make sure it's very precise. The second equation we have is x plus y equals 6. So same idea. We'll solve for y. So to get the y by itself, we have to get rid of the x term. So since it's a positive x, we'll subtract the x. Cancels it out. And that leaves y by itself equal to a negative x. And then since it's a positive 6, it's plus 6. So we have our y-intercept at positive 6. So that'll be 4, 5, 6. That'll be right here. And then our slope is down 1. It's negative 1. And negative 1 as a slope means down 1 and then right 1. So it'll go something like this. And so these two lines, they cross at this point, which is 2 on x, 4 on y. So our answer is the point 2, 4. All right, so number 3, now we're using substitution method. I like this method. So what we have here is we have y equals x minus 4 in one of the equations, right? So what it's telling us is y is literally equal to x minus 4, which means that these two things are the same thing, right? They can be substituted and whatnot, okay? So if I told you that y was equal to 5, right? All you would simply do is just plug 5 in for y, right? But so it's the same as that. We have y is equal to x minus 4. So what we're going to do is we're going to take x minus 4, we're going to plug it in for y. Simple as that. Take this, plug it in for y. So the equation, I'm going to write this equation out, but I'm going to have the x minus 4 plugged in as y. So it'll be 4x plus, and remember, this is where y was. It was 4x plus y, but I'm taking the y out, and in its place putting x minus 4 equal to 1, right? So this was 4x plus y equals 1, but like I said, I replaced the y with x minus 4, since y is equal to x minus 4. Now, because there's no number in front of this to distribute, we can simply kind of just drop the parentheses. So we can kind of write it just like this without the parentheses. That might make this a little bit less intimidating. So all we're going to do is combine like terms and we'll solve. So we're going to try and find x here. So we have 4x plus x, and that's 4x plus 1x, which means we have 5x. And then I can bring everything else down. The minus 4 equal to 1. So now we'll add the 4 to both sides, cancels that out. So we're one step closer. We have 5x on the left, we have 5 on the right. So if we divide by 5, we end up with x equal to 1, because 5 divided by 5 is 1. So our x value is 1. So now we can take this x value, plug it back in, and find y. So if x minus 4 is what y equals, and x is now 1, then we have 1 minus 4. Right? Because x is 1. So 1 minus 4 is negative 3, so y is equal to negative 3. So our answer is the point 1, negative 3. Number 4, it's pretty much the same thing, right? We're going to take this y equals x minus 5. Since y is equal to that, we're going to take it and we're going to substitute it into y. So this would look like 3x plus y equals negative 3. But remember, we're taking the y out, and in its place we're putting x plus 5. So you see, like I said, it used to be 3x plus y equals negative 3. But we took the y out and we replaced it with x plus 5. So now again, we just kind of solve it. So again, because there's no number to distribute here into the parentheses, I'm simply just going to rewrite this without parentheses because it's not needed. So same as the last problem, basically. We have 3x plus x. That's going to give us 4x. Bring down everything else. Bring down the plus 5 and the minus 3. Then we'll get rid of the 5. We'll subtract 5. This will leave you with 4x equal to negative 8. Negative 3 minus 5 makes negative 8. And then we divide by 4. And we get x equal to negative 8 divided by 4, which is negative 2. So x is negative 2. And like I said, we can take this information, we can plug it back into the equation and find out what y is. So y is equal to x plus 5, but x is negative 2. So negative 2 plus 5 is 3. So y is equal to 3. So again, if you're wondering how I got 3, it's because I took x and I plugged it in. X, remember, is negative 2. So if it's x plus 5, then I have negative 2 plus 5, and that's how I got 3. Number 5, again, pretty much the same problem. We have y is equal to x plus 4, so we're going to plug that in to y for that equation. So the equation is going to be 2x plus x plus 4 equal to negative 5. Because remember, it used to be y here, but I've taken the y out and I've plugged in x plus 4. Same as before, there is no number in front of this parentheses, so there's nothing to distribute, so I will keep it, or I'll just simply take the parentheses off, just to make it easier to visualize the problem. And so now again, we have, the same thing. 2x plus x is going to be 3x. We're going to bring down the plus 4, bring down the minus 5. We'll subtract 4 on both sides to get that canceled. And that'll leave you 3x equal to negative 9. And then when you divide by 3, we end up with x equal to negative 3. So x is negative 3. And just like before, we can take that, plug that in. So if x is negative 3, then y equals negative 3 plus 4, right? Because x is negative 3. So negative 3 plus 4 is simply 1. So y is equal to 1. That gets our answer. Number 6, in our last substitution problem, again, it's pretty much the same as all the other substitution problems. So if you want to, maybe pause the video and try this one out on your own, that would be encouraged, and see how you do. All right, so we're going to plug in x minus 3. So we're going to have 5x plus x minus 3 equal to 3. So remember, this is where y was. I've taken the y out, put x minus 3 in its place. So now again, because there's no number here, I'm just going to get rid of the parentheses, rewrite this without the parentheses. All right, so let's combine x terms. 5x plus x makes 6x. Going to bring down the minus 3, going to bring down this 3. We'll add this 3 to cancel it out. And that leaves you 6x equal to 6. Divide by 6, and we have x is equal to 1. So now that x is equal to 1, we can plug it back in. So since x is 1, we'll have y equals 1 minus 3. And 1 minus 3 is negative 2. Okay. So again, I kind of did that problem pretty fast simply because it was the same as the previous 3. So I apologize for going kind of quickly, but yeah, I did all the real detailed explanation back in number 3, all up there, because all these problems are pretty much the same thing. Now let's look at the elimination problems. So for number 7, okay, here's the catch with the elimination problems is you have to have something cancel out, right? So when you look at number 7, notice we have 3x plus 2y equals negative 7 and x plus 2y equals 11. So what we're going to do with elimination is just add the equations together, but only if we can make sure that one of the variables cancels out. So if we were to add them together now, 3x plus x would be 4x, 2y plus 2y would be 4y, and it doesn't really matter what the rest part is, but that would be 4 as well. Now, this is not what we want to do, because notice, we didn't eliminate the x, we didn't eliminate the y, so this equation here was basically useless. So you can't just do that. You can't just jump to adding the equations together. You have to make sure something eliminates first. Now, when I look at this problem, I notice that these y values, there it goes. My pen wasn't working for a second there. It's a little laggy. These y values here are close to canceling out, right? They're both 2y, but in order for them to cancel out, one of them has to be a negative 2y. So this doesn't really matter which one you want to try and make negative, as long as you do make one of them negative. So I'm going to take the bottom equation, and the way I can make a positive 2 turn into a negative 2 is by multiplying it by a negative 1, right? Because negative 1 times 2 would give me negative 2, and that's what I need in order to cancel out with a positive 2y. I would need a positive 2y and a negative 2y. So I'll leave the first one positive 2y, but I'll multiply a negative 1 to this equation so that this can become a negative 2y. So what I'm going to do is I'm going to rewrite my system out. So I'm not going to change my top equation. I'm going to leave it 3x plus 2y equals negative 7. But for the bottom equation, I'm multiplying everything by negative 1. So negative 1 times x will be negative 1x. Negative 1 times 2y would be negative 2y. So you can see they're going to cancel out now, which is good. And then negative 1 times 11 is negative 11. Don't forget to do that last term as well. So now we can actually add the equations together. So I say add, it's really just kind of like combining like terms. So 3x minus 1x is simply 2x. 2y minus 2y is going to cancel out. And then negative 7 minus 11 is going to be negative 18. So we have 2x equals negative 18. So just divide by 2. And we have x equal to negative 9. So x is negative 9. So now what we can do is we can plug this back in to one of the equations and find y. So let's take the second equation. The second equation was x plus 2y equals 11. But x is negative 9. So we're going to say negative 9 plus 2y equals 11. So to solve this, we'll add the 9 on both sides. Cancel it out. That gets me 2y equal to 20. And then I can divide by 2. And I have y equal to 20 divided by 2, which is 10. So y is equal to 10. So there's a process of elimination. So we're going to have the same issue in this problem here. Is we can't just add them together because nothing cancels out. Negative 5x minus 7x would be negative 12x. Negative 6y minus 6y would be negative 12y. They don't cancel out. And negative 6 plus 6 would be 0. So what we're going to have to do is pick an equation and multiply it by a negative again. Because what I want is I want these 6y's to cancel, but they're only going to cancel if one of them is positive and the other is negative. So I'll leave one of them negative, but in order for the other one to become positive, and this time I'll choose the top equation, but it doesn't necessarily matter which equation I choose. I could do the bottom instead. In order to make a negative 6 turn into a positive 6, it has to be multiplied by a negative 1. So I'm going to multiply by negative 1 to that equation, do exactly the same thing we did number 7, and that will convert that negative 6y into a positive 6y, which can then eventually cancel out with the negative 6y in the equation below it. So let me do that, and let's write our new system out. So the negative 1 times negative 5x will be a positive 5x. The negative 1 times negative 6y would become a positive 6y. And the negative 1 times negative 6 will become a positive 6. And the bottom equation, I'm not going to change anything about it. I'm going to leave negative 7x minus 6y equals 6. And the reason I'm not changing it is because now, with the way it is, I have 6y minus 6y, and that will cancel, which is good. So now I can add these equations together. So 5x minus 7x is negative 2x. 6y minus 6y is 0, cancels that out. And 6 and 6, you're adding them, they're both positives, that's going to make 12. So we have negative 2x equal to 12, so divide by negative 2. And we have x equal to negative 6. So x is negative 6. Like I said, we can take this information and plug it back in and solve for y. So I'll take the first equation, negative 5x minus 6y equals negative 6. But I'm going to plug that into x. Plug negative 6 into x. So we'll have negative 5 times negative 6 minus 6y equals negative 6. So when I multiply these together, negative 5 times negative 6 becomes a positive 30. And then so I'll subtract 30 to cancel it out. And so this gives me negative 6y equal to negative 36. And then divide by negative 6. And I end up with y equaling a positive 6. So our answer, negative 6, positive 6. Now, the last two problems are even easier. They're more convenient simply because they're already set up to cancel out, which is very, very nice. Because if you look at number 9, negative 3y and positive 3y are already going to cancel out. So there's nothing I need to change. I just simply have to combine the equations together. So negative 3x minus 6x become negative 9x. Negative 3y plus 3y is going to cancel out. Very nice. And 15 plus 39 is going to make 54. So now just divide by negative 9, and we have x. X is going to equal 54 divided by negative 9, which is negative 6. And now, like I said, we can plug this back into another equation to find y. So I'll plug it into the bottom equation. So the bottom equation was negative 6x plus 3y equals 39. I'm going to plug this in for x. So we're going to have negative 6 times negative 6 plus 3y equals 39. So when I multiply negative 6 times negative 6, it's going to give me a positive 36 plus 3y equals 39. Subtract 36. So this will be 3y equals 3. And then divide by 3 to cancel that out. We end up with y equal to 1. So we've got my final answer. And so we just have one more equation. It's pretty much the same problem. We're one more system. Like I said, pretty much the same problem. The y's are already going to cancel out here, which is very, very convenient. 4y and negative 4y will cancel out. So we're good. We're good to just go. So negative 3x plus 6x will become a positive 3x. 4y minus 4y is going to cancel out. And negative 22 plus 40 is going to be 18. So I have 3x equal to 18. Divided by 3. We end up with x is equal to 6. Again, lots of 6's there in this answers section for some reason. Okay. So if x is equal to 6, then we can take it and we can plug it back in and find y. So I'm going to plug it in the second equation. So the second equation was 6x minus 4y equals 40. And I'm going to plug that 6 into x. So we're going to have 6 times 6 minus 4y equals 40. And when I multiply this together, 6 times 6 is 36. I'm going to subtract that 36 to cancel it out. So negative 4y is equal to 4. And then divide by negative 4. So we end up with y is equal to negative 1. And there's our final answer. So, grand scheme of things, this is the overall study guide, all completed for you, all the work shown, everything kind of explained. If you want to, take a picture of that screen, that's good. You'll notice all the answers that we got should be the same as all the answers provided down here. Okay. So everything looks good. But yeah, there it is. Good luck studying. Go back over, rewatch any problems that you guys need to. Remember, you're not really ready unless you can pretty much do this whole thing from memory. If you can rework every single problem on your own from scratch, that's when you know you're ready. So if you can't do that yet, I suggest you keep studying. All right. Have a good day. I'll see you guys. Good luck on the test. Bye.